Okay, folks. 6:30, 6:31 now. Can y'all hear me okay?
Yes, I can.
Fantastic. Okay. I am still fighting with the webcam issue. Not that I'm much to look at, but and we're on the share screen mode. That's it. Most of the time anyway. But sorry, not trying to hide from you or anything. I just haven't had a chance to really talk to IT more, and I forgot about it when I taught this home. So I'm going to go ahead and start sharing the screen. Make sure I'm on the right thing when I do. And then I'll do. Okay. Now I am at home again this evening, and everyone has strict instructions to leave me be. So after this is over, I'm going to keep talking to myself for another. No, just kidding. All right. So, all right, this focus here, our third and final Zoom session, is your proctored final exam, which everyone is so excited about now. My goal right now in this session, and I'm going to do it with the assistance of these notes I put up. I think it was yesterday. It might have been. I think it was yesterday. I have a folder, right? I have a Proctored Final folder, okay? And right, this is the instruction video. I don't want to talk too much about the procedure for taking the test right here. Most people are tuning into this to get an edge on what's coming on the test for material. The notes that I was just referring to are right here. So I'm going to open those with you right now. I also brought, and I guess this might be a happy accident for being off camera. I also brought a paper copy of the test, which there's really no reason to have anymore, but I printed one out before I came home this afternoon, thinking that, oh, it'd be easier to talk through and remind myself of things. All right, so this is the preview, right? And at the beginning, right, I've got my a little bit, it's not nearly the same length or ridiculousness of the full instructions. I don't know. I'm just going to say one more time. Everything you want to know about the procedure for taking this test is in the video from yesterday. It's also the instructions are in the have been in the announcements for a while. I made a mistake in one tangential part of it and cleaned it up, but they've been in there since October 17. And but by far, one-stop shop. If you go to the quizzes area, please, I beg of you in the next few days, if you haven't already, do it soon, like really soon. Go take the practice quiz because you'll be forced to read all the directions and you want to read those well in advance so that you have the right materials in the right spot, that you understand what's happening. And I have to cover my fanny with a lot of legalese in a way in there. It's very commonsensical, and I'll try to do the 30-second version of it again, even though I know we're talking content. Uh, it's like you don't want to read all the legalese for like a few minutes while the clock is ticking. Just see it because the timer starts ticking when you enter the exam, right? So don't, this is the real one here, right? But you'll get the same situation. You'll have access to the same e-tools, which again, I don't think people really want to rely on much. I think some paper notes and the calculator is really the key to this, along with your writing utensils and your photo ID for the check at the beginning. Um, you know, but say the gist of this is we have 3 hours. When you join this, right, you're going to get the whole, and this is the practice one, right? You're going to get all the legalese here, right? Back to the rules is that it is ridiculously long, right? If you've been paying attention to like the video, but it's probably easier to absorb via video, then it's not as bad as you think. But it's basically saying, hey, we do this by launching Respondus. Just like I'm in Chrome right now, you have to download Lockdown Browser, I should say. Lockdown Browser is the name of the browser, obviously. And that's the only thing that'll be open on your machine while you take this. You'll view the questions on screen. They're just images. You'll have access. You can have anything you want on paper as you prepare. And I've also got at the end of the exam a bunch of links to things you could open. I do not think you're going to want to peek at your book, at any old data sets. I don't, I hesitate to even sometimes make them available, but I don't know. I kind of feel obligated to. I have some blank Excel here to work with, but it's not the nicest Excel, and a pocket calculator will get most of this done. In theory, I suppose people would access some slides at something, but with a 3 hour clock ticking, you're not going to want to do that. I don't think either. So really, my image is have anything that you think would really be useful on paper, especially after tonight when you know what's coming. Have your photo ID, your calculator, some blank paper to write answers, and any other paper resources you want. Open the exam while you're using Respondus as your browser. You'll read it on the screen and you'll write your answers down. All right. When you're done, back over here in our assignments area, there's a Dropbox to upload your answers. I'd prefer if you'd please try to use this Proctored Final Dropbox right here. You're going to take images of your handwritten answers. Please try to write nice and dark as you do it and label your pieces, 1A, 1B, 1C, etc. And that's it. You upload the images there. I would check if you're using your phone for the images. Most people, fewer and fewer people by the year have like a scanner. Right? In theory, you have 10 minutes after the exam window ends to get these uploaded in the Dropbox. If it's 11 minutes or 13 minutes, there's no like fear of execution or anything like that. Right? But the files cannot be .heic files. Some people's phone pictures are .heic files. It won't even let you upload those because they don't come through in this system. You upload them and you're done. You can email them to me as a backup, but again, I'd prefer that you try to upload them here in the Dropbox. You can see that it's open for the 3 days that match our exam window period. All right. Did I do that successfully in 5 or 6 minutes? So there's more detail about all sorts of little things that people that have come up over the years. If you really hate this, let me know fast and we can try to find you a local testing center to take it instead on paper. Because I think this is ridiculous. I don't like doing it. I didn't get into this to be I even like grading. I don't mind grading, but I don't like playing stupid internet test police. But nowadays, that's how most of these, it seems, have to be done. All right. I'll shut up about that. Is there anything super pressing that anyone wants me to try to clear up though first?
I do have a question.
Okay.
So this might come as an odd question.
Go for it. Go for it.
So when I was going through the practice quiz and I went through the video, you were talking about how the questions were a series of images. So that means that the questions are visible right on those images.
Yes.
We're not clicking anything to reveal a question.
Correct.
Okay.
That is my that's when I learned, you see. I used to do something a little different, and then I realized, oh, there was some little glitch with something or other. And so I started doing pictures of them where the pictures would just show up automatically on the exam instead. And no one's had an issue with that ever since in the last few iterations. So that wasn't always the case, and your intuition that could be a problem is correct. I'll even show you guys again briefly right here. I promise I'll move to the hints in a sec. If you look at the actual exam itself, which of course I can do because I'm in the instructor mode right here. Like, look at the preview. I think I showed this really briefly with y'all. It is a series of images. So after those same pasted instructions yet again, right, here comes some images. This is just a reminder about uploading the pieces. And look, you can even peek. There's the binomial table. So it's just like the binomial table is an image in the practice quiz. Then there's the beginning of the first question, right? That you can see on your price on your house and it's a price of a house closing and the time that the house is listed on the market, right? That's how they're all basically going to look, and they're all just in order. And then after the 9 questions, yes, there's 9 of them, comes those links and other outside resources, which I don't necessarily think folks will need much of, but they're there.
How many questions total?
Yes, 9. There's 9. In fact, I'm going to talk through all of them right now. That's a great question.
Does that count the multiple parts?
No. If you add them up tip to tail, I couldn't tell you. It's got to be into the 30s for sure. But some of them are very like, hey, what's the mean of this? Or what's the probability of this? 0, right? What's the problem? So don't be shy. And I'm going to list off kind of the parts right now, even. So It's if you add them up tip to tail, I guess I could peek at my paper in front of me, right? 7, 10, 15, 20, 24. Looks like about, I mean, if you literally count every single little item as its own item, yeah, 30 is probably 30 something, probably low 30s is probably the grand total if you add up all the subparts. What else you guys thinking? Okay, great.
Sorry, quick
Great.
question
Well,
about
that,
the lockdown browser. I
yes.
downloaded it. It said it was successful, but then I still can't view the quiz.
Okay. That's when we probably want to get together on a Zoom for some of you who are still having issues. I don't have it on this machine actually, but yeah, if everything else is closed, now I've had folks that have had to re-download it before, but we definitely want that to be working on the practice quiz in the next few days here so that we know it's ready to go on the real one. Because yeah,
Okay.
it's that's when we want to make sure. And sometimes I am not an IT person either. Sometimes I end up just roping in those folks fast from ITS, and they're usually very kind. Um, but yeah, let's. If it was me, I would uninstall, redown Lockdown Browser, try launching it again as the only thing at all on my device, and then trying to get in the practice quiz and see how it goes. And if
Okay.
it's still not, then say something, please, to me, and we'll get you pointed to someone that can help us.
Okay, thank you.
Okay, let's tell you what's on this sucker then. This is more fun. I always dread that 5, 10 minutes. It's usually 10. You know me, it's probably even more usually. That was good for me. Let's tell you what's on this sucker. All right. So did I open this already? Yes. Okay, I did. Right. So the first part of this is just telling now, hey, like if something crazy happens, you don't need to text me in the middle of the night or anything like that. I'm no offense, but there's nothing I'm gonna be able to do about it like immediately anyway. Make a note. Do as much as you can. Do your best. Usually with 140 some people, my experience is there's going to be a couple few people that get the whammy, right? Most of the time it goes great for most people. Knock on wood, cross fingers and all that. But if something crazy happens, just make your best honest effort. You're on camera, you're fine. Just do your best, right? And then let me know afterwards. I'm, despite sometimes appearances or whatnot, I can be a reasonable guy. I can say I can be, right? All right. The spirit of many of our quizzes is really useful. I think that's true when I think about things like F tests or using the correct level of, testing, significance testing, whether I want to be aggressive or conservative. I really try when we construct those checkup quizzes to be like mindful that I know some of these little things that are going to come up later. All right. So starting here on this next page, I have, you see them numbered. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to talk them out with you here. I want you to know what's coming. I understand we've all been there where we had an exam, a big one. And then some instructor tells you that it's going to be about X, Y, and Z. And instead it was about A, B, and C. And it was completely jarring and it throws our confidence before we even start. I really want you, if you want to, once you open the exam and start taking it, I want you to be able to flip through it for like 30 seconds, just a peek and get that sigh of relief that comes with like, okay, it's exactly what I knew. It's exactly what he said was coming. And then you can relax perhaps a bit and potentially get in a groove where you can just do your thing. That's the goal. That's the goal. And that's done right here. So the very first question, I even showed you a teeny piece of it. It's literally the question. It's mimicked or taken in large part from a practice problem from chapter 5, from part 2. And I think we're going to take the time here. Again, it's one thing with take homes where y'all have access to them in advance and can think about what to do with it. In this case, where you don't really know what's coming, and I can try to win you over and have you believe me, but it ain't the same until until you see it for yourself. You'd have some hesitation. Here's our practice problems from week 2, and these are going to be useful for a few things here. So if I go back and look at the sheet, this is the preview document sheet yet again. It says probability, this is question 1. Marginal probabilities, conditional probabilities, independence. Chapter 5, part 2. Problems 7, 8, 10, which I didn't even assign actually, 11 are good ones. Now, remember, you have the solutions manual, so you can look up this even to 10 if you want. But when I look here at, I say 7, 8, 10, you've got some like contingency tables, right? This is a 2x3, full-time, part-time, business engineering and others. And I don't need you to do A. There's no Excel here. There's no pivot tables and probability tables, right? I want to make sure of something before I forget. Yeah, I guess those are okay. I'm trying to make sure that, yep, it does. Okay, good. Yeah, no pivot tables, nothing like that, right? But I do have, I've got number 11, I think, is maybe my favorite of all. So 7 is good. 7 is fine, right? 8, they actually use probabilities inside the table instead of raw counts, which isn't bad. And most of the calculations you do still work the exact same way, but it could be a little jarring. This is literally where I started when I created this problem. I've got 3 different lengths of time, and I've got 4 different price ranges. So just like number 11 has here from week 2, from chapter 5, right? I've got the same kind of, they're different numbers inside of everything, but the layout is the same, right? 4x3 or 3x4, however you want to call it. And then just like here on 11, I introduce 2 events. Now I call them A and B on the exam as opposed to A1 and A2, right? But I say, oh, well, A1 is the probability, event A1 is the event that a home is listed for some length of time. So if it's under 30 in this case, you're talking about this event that corresponds to this column on the left. If I said over 90 days, then event A would be corresponding to these observations here on the far right column. Well, not the far right, but the rightmost marginal column. That's event A. And then event B on my exam question is, well, what's the price? Here, it's a price range. Event B is that you fall in a certain price range. So it might be the top row under 150. It might be the third row, 200 to 250. But I've got something very similar, right? And again, it's 4x3. So I literally, the first 2 questions, so 1A and 1B are, well, what's the probability of A? Well, what's the probability of B? Well, you have subtotals here in the bottom here underneath the columns, and you have subtotals here on the right, over, to the side of the rows. So literally for the first couple items here at 1A and 1B, you can literally just, now I'm not going to be this direct about every question on here, but you can literally just divide the row total by the grand total or the column total by the grand total, just corresponding with the events. And it'll go really well. People will get them right. All right. But that's the first 2 items, right? So, right, we are motivated by this table, but I've actually got some stuff here that's even easier. Right. Now, the next thing on the exam, right. Oh, I'm sorry. I'm looking at the wrong thing up here. There we go. Yeah. The A, B. Oh, okay. I'm sorry. I was looking at the wrong ones. Yeah. So mine is the same. A and B. Sorry. Stage fright. Chuck that reverse. It is just like A and B. Cool. And then I also have the same C. I've got what's the probability of the intersection of both A and B. Well, then you'd have to locate the one specific cell where they overlap, right? That's C. And then I have a D that's not on this old 11. It's the union. It's the probability that you're either A or B, right? But again, you can literally just add up the counts that apply. Hey, this would count, this would count, this would count, as long as it's in either the row or the column. You're careful not to double count the intersection where they both are. And then, right, divide that by the grand total, right? So that's A, B, C, D. Then I do have conditionals, right? I do have conditionals. And I actually just use the math version of that. I say, what's the conditional probability of A given B? And then I also ask you, what's the conditional probability of B given A? Now, that's somewhat like part D here, right? but I wrote it out in the math form and I did two of them. I went either which way. Mm. But say, if I tell you that you're in a specific column, and then I ask what's the probability that you're in a row, then you can ignore the other columns, right? And analogously, when you do the conditional the opposite way, just make sure that when it says given, right, that you're reading it in the traditional conditional way that we worked on together. And then I have a final part of the first question that says, are A and B independent? You've kind of caught the trend, I suspect, at this point that like independence is a really high hurdle. Now I ask you to provide a calculation, right, to demonstrate whether it is or is not independent. And there's all kinds of ways you could go with that. But some of the work that you would have done above for parts A, B, C, D, E, F would already be enough evidence to answer this final part, G. Are they independent? Mm, you just got to cite it. Mm. All right, what do you think? That's my recipe for the kind of direction I want to give you. See, my thinking is I want you to study. I don't want to give away too much specificity like weeks in advance because I want you to go over everything. But when we get here 4 or 5 days out, I want to really, really give you some hints and focus because it's a crap ton of material. So, anything on one? Did that clear as mud?
Quick question.
Sure.
Yeah, so just to clarify,
Hmm.
try to like be best informed on the study practices here.
Yes.
So I know like that one looks very familiar as to what we had on our take home as well, which was
Yeah.
obviously different because we had Excel. But I guess my question is the best practice for all these as we go through to study, like use our examples, pinpoint some of those areas in our slides, and then kind of rework through some of these example problems and just kind of understand what each term means, and then maybe have a kind of a source like piece of paper that we create for our exam that's kind of a like an aha reminder of what we covered during our preparation time.
If everybody followed that recipe, I think the average on this would go up, 10 points or something. It's already fine, right? But now there's more than one way to do it, Brandon, to prepare, and everyone's a little different. I think that's a great plan, especially here when I'm pointing you to some specific examples to make sure you go readdress and some other and I have some slide numbers even coming up. I actually have some timestamps from presentations even here for you. And so if you take tonight's and this sheet's content and go try to reconnect them, then I think you're going to be in great shape. Of course, you could print like paper versions of all 5 slide presentations and have 432 slides or something in front of you. I don't think you're going to want to do that. I think you would benefit, especially kind of predicting what's coming pretty easily. I do think you'd get something from that process of making your own quote unquote cheat sheet. It's not cheat sheet, it's totally fine, but making your own thing, right? I like that plan.
Okay. Yeah, I think that's good feedback. I think that was my primary concern was just what to take into like, preparation's all
Yeah.
good. Get to the
Yep.
exam and you go, "Oh, I
Yep.
remember covering this. What was that? What did that mean?" Just so trying to be intentional about what's included on that sheet to
I,
bring in to say, "Ah, okay, I know what he's asking me."
Yeah, I think the exercise of putting that together, if it's pointed, if it's not just trying to do, I mean, don't get me wrong, it'd be fine for anyone to independently try to summarize the whole class, but that would suck and take a lot of time. If you do that with a real eye on what we're doing here, I think you'd be in fantastic shape. Yeah.
Perfect.
My dad tells a story. I hadn't told in a while. Maybe I'll ask him about some advanced math class he took in college, kind of like the ring theory or analysis or linear algebra, one of them type of things. And you had a kind of a really weird professor. I mean, I don't know. I can't identify with that. Ha! But they got to do a cheat sheet and they got to bring it in and they were like rip roaring ready to go. And then the professor went on this like super like it kept going on this tangent and then eventually like culminated with like, and of course the real answer is there is no test. The entire preparation for this was the test itself. And it's like, huh, Well, that's not what ours is going to be. Sorry, but yeah, see, but that made an impact because he remembers that 60 years later. So, you know, maybe my last year, maybe on my way out the door or something. I don't know. Like, all right, all right. Sorry, yeah, we have a real test. Sorry. Two, I say the discrete uniform and custom discrete distributions, including a die example. And I talk about the mass and density function, expected value. I'll be more specific and show you what I mean. I say chapter 5, P3 means problem 3, right? So same sheet, actually going to go backwards here to number 3, where you roll a pair of dice. Now, we did this, we did dice, that's why they call them that, back in week 2, right? And we first started with one die, and it was uniformly distributed discretely, right? Because you had 6 things and they were all 1/6, right? And then we did a pair of dice, and well, of course, it's not going to be uniform anymore because you can roll a 7 more easily than you roll a 2. You play any of the new dorky board games and stuff, very probability heavy, or just play craps, like you learn that stuff really fast. I have a different kind of distributor. It's a die, but it's not a regular die. The spots are weird. That's my question 2. So instead of being 1, 2, 3, 4, 5, 6, now I'm not going to tell you what it is, but I've done ones before where I did like 1, 1, 3, 4, 6, 6, right? So you've got 2 different faces with a 6 on it, 2 different faces with a 1, as well as a 3 and a 4, right? I have something like that for you on your second question. It's a goofy die, and it's supposed to be a pretty quick question. It's got 3 parts, A, B, and C. Right now, you can garner something from this if you go back again to it's about the hour 28 mark. I feel kind of guilty and embarrassed even referencing my timestamps and videos to that when I have an hour in it. It's kind of embarrassing. But hey, like I told you, pause. Sorry. The first question is, hey, just tell me the probability mass function of this event. i.e., write me out a table if you want, and just tell me how likely it is to do these different things. Well, if you had a 1, 1, 3, 4, 6, 6 on your die, what's the probability you roll a 1? 2 out of 6, or 1/3, right? Sure. 1/6 the 3, 1/6 the 4, 2 6 or a third, a 6. It's a simple. That's all I'm going for. It's not a trick. The die is goofy. It's a tricky die, but it's just, hey, write out this isn't uniform, of course, when I give it to you. So while we first introduced a uniform like example to talk about some of these things, the one on the test ain't uniform. The second part B is, well, what's the expected roll? What's the expected value of your roll? Well, if you know the things that you could roll, and you know the probabilities of each of them because you just listed them out for me in the first part of the question, the expected value is pretty darn easy. All right. And then the last part, there's only a third part, C, on this second question, is, well, what's the probability I roll exactly the expected value? Now, you did one like that on Take Home 1 with the insurance problem, where it's like, oh, 800 is the expected value. Oh, and 800's on the list. So the probability is 8%. Now, that's very different than with a continuous distribution. With a continuous distribution, there is 0 probability of any exact thing happening, right? It applies naturally to things like weight or height or length or time that are continuously structured. But that ain't the case here. So here you got to use your noodle. Is your expected value one of the things on the list? If so, just look up its probability. If it ain't on the list, then the probability is 0. Bada bing, bada boom, you're done. And that's it. That's the entire second question. Do 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 do. What do you think? Clear as mud? Now, I had a few eager beavers take home time that were ready to pop that binomial. No, it was too early. There was nothing binomial in your take home one. There's binomial on this. I've got a binomial question. This is the one question where it's like, okay, I kind of wish if you wanted, you could do it in Excel. I mean, we demonstrated how to do it in Excel, obviously. It's around the hour 34 mark, right? Back from week 2. And say this is still chapter 5, which is still part 2. I told you there'd be a lot of week 2 stuff, probability here relatively on the proctored final. I say numbers 24 and number 26 as practice problems. And note, I've also got a binomial table on the proctored final, right? I think the binomial table, maybe I'm just showing my age. I think a binomial table, for the purposes of the things I'm going to ask you, is easier to use than the stupid Excel function, right? Now, you've had a binomial table in here for quite a while. I think I put it like between weeks 1 and 2. Yeah. So this binomial table here is the same binomial table image anyway that I've got on the test. This is making me feel young, right? This is the kind of things in the back of my stat books and stuff. Okay. It lists the probabilities that you could be curious about across the top row. And then on the left column, it's like, oh, like, hey, look what happens. If you flip a coin twice, n equals 2. What's the probability? You have to make an event. Let your x be heads or tails. Remember, binomial, there's only 2 things that can happen, and thus the probabilities have to sum to 1. A coin is really easy because it's 50-50, 0.5, 0.5. So I would be looking at the 0.5 column with a coin right over here. Well, yeah, let's make heads be, x. That's the event of flipping a head. Well, you know this, you think it through. You flip a coin twice, let's probably get 0 heads. 25%, right? That's how you read the table. Yeah, because the only way to get that is 0.5 times 0.5. They're independent, so you can use the multiplicative rule and you're done. You could roll. I keep saying roll. One head in 2 flips, 50%, right? Yeah, because you can go heads, tails, or tails, heads, and those both would count, right? And then a 25% chance of 2 tails, 2 heads. I'm really butchering the discussion, but I still think you get it. The point being, I've got a picture of the binomial table on the exam. I don't really feel that bad about you missing out on the Excel function because this sucker's easier to do with an old school table, right? I say number 24 and number 26, as you would guess, go down to those. There are a couple binomial questions. So 24 has a 1% as kind of the key number. I don't remember. Is 1 even show up on this? Nope, it doesn't. See, 1% ain't even on the table, right? So this ain't a perfect, but that's because I'm really into 26. 26 is basically what I wrote the question based on. So when you look at 26, it talks about a university and having 20 students, and they either withdraw from the class or they don't, right? So there's only 2 things that can happen. Their probabilities have to add up to 1 because either you withdraw or you don't. So 0.2 and 0.8, right? 0.2 being the P, if you will, in this case. And it says, compute the probability that 2 or fewer students will withdraw. Well, with 20%, P is 0.2. And if you have 20 students, now this binomial table here, right? Only, I think can I see the whole thing on this? I can't remember. That's just a photo of the first part, right? But you got a full table in your ebook, which again, you don't need I pick one for the test that matches perfectly with the table. Yeah, there's just a picture. It doesn't go down to 20. Yeah. So you can use the actual table in the book if you wanted to practice that one again. You could use the Excel during your practice. The one I have for you, I've only got like 7 students, I think. No, 6. Yeah. I've only got 6 students. Right? Or it might be 5. Well, whatever. That's good. I don't need to tell you. And I give you the probability of the students. I don't make them withdraw. That seems too mean. So I have them something like, hey, they're either like this percentage of the College of Business students are accounting majors. And I give you a probability. And it's one of the probabilities that's right here on in the top row. And then I make the sample, the grand total, 5 students or 6 students, something you can easily look up right off the table. And then I got a series of questions about them. What's the probability that exactly 2 of them are accounting majors? What's the probability exactly 4 of them are accounting majors? What's the probability that 1 or fewer of them are accounting majors? So 0. You can literally just add the probabilities if because these things are going to add up to 1 in each of these little sections. So I've got a few little ones like that. And then I ask you for the expected value. Well, there's a formula for the expected value of a binomial. It's pretty commonsensical, right? Like, oh, you got somebody with a 300.3 batting average. They have 10 at bats. How many hits do you think they're going to get in the 10 official at bats? Yeah, zero point 0.3 times 10 is 3, and that's the answer. Right. So the next question after a few specific ones where you can draw them off the table is, hey, what's the expected value? Right. And you got a formula. It's a pretty commonsensical one. I basically just said it again. You can go look it up too, if you will. If you're compiling a sheet or something, that would work out great. And then I conclude, last part of this one, I do ask you for the variance, or no, I ask you for the standard deviation, excuse me, of the number of accounting majors. Because yeah, I use accounting majors in the College of Business as kind of the silly talking point. Well, unlike the expected value shortcut formula for binomials, there's not really, I mean, you can derive it if you take like a math stat class, you can derive like the standard deviation form. It's fun, it's even on Wikipedia, but that you don't have to do it from scratch. You can just apply the formula you got in class. It is one thing that, yeah, if I was preparing a cheat sheet or just printing some stuff out or writing some stuff down in advance, I'd make sure I had the standard deviation formula for a binomial distribution. It's only for like a couple points, but I do ask you to do it. I do remember with you in the presentation too, kind of showing you that like, oh yeah, see, if you do it this way, right, you can come up with it and you can use the binomial properties or you can do it the old school way. So, but you don't need to do it the old school way. You can use the formula. I'm looking at Rhett's key as I do this, and I'm noticing how he uses Q instead of 1 minus P. I'm like, oh, I never noticed that before. See, Rhett grades these. While I'm grading take-home twos in Excel, he'll be grading these. And he's good at it. He's done it for me for many years, and the questions change, but he knows what to expect. They're still always on the same topics and whatnot. He does a good job. Rhett's much more of a like incremental grader though. Like he's like, well, this part is 1 point, and this part is 1 point, and this part is 1 point, and this part is 2 points. Now we come to the same final grade or very close the way we do it, but the stuff I grade's a little more hazy. So I'm a little more holistic in things, whereas he just tends to break it into pieces and award the credit for little pieces, little pieces, little pieces. All right. How about 4? All right. I've got a continuous uniform question on 4. Talk about, which again, I never liked this example, but it's hard to come up with a better one anyway. Hey, this flight to from Chicago to New York is going to land definitely between 120 minutes and 180 minutes or whatever it was, right? But it's uniformly distributed between 120 and 180. I guarantee you that ain't how it works. I guarantee it's normally distributed like a lot of things in nature, right? And yeah, there's some variations and outliers and winds and flyovers and traffic pattern. But point being, right, that was the initial version we did of this, right? And then I say from the back of the chapter, numbers 31 and 33, A and B. But I bring that New York, Chicago example up. It's around the hour 49 mark. Again, still in week 2, part 2, right, chapter 5. I say boring because I look at number 31 here. They didn't even put any like fun real world example into it. They just stuck to the real math on it. Hey, you got a continuous uniform distribution that goes from 10 to 20. It's a rectangle, right? It's a flat rectangle. That's the whole point again. And because it's a flat rectangle, you can just use the same old area that you learned in school, length times width, right? And compare whatever event you're looking at as a section, right? And compare it to the total in that piece, right? So if you go from 10 to 12, the probability is 20% in this example. You kind of know that intuitively, right? Because yeah, well, 10 to 12, that's 20% of the total from 10 to 20. Right. Well, what you did in your head was you said the width of that rectangle, the little one, was 2, and the width of the big one from spanning the whole thing is 10. And you did 2 over 10 and you got 20%, 0.2. Right. You don't have to do any calculus here. There's no integrating to it. That gets fun when you get to some of the deeper parts of this. But the nice thing about the uniform continuous is the calculus is not even calculus. It's just arithmetic with your good old school area. I've got a question, right? In the premise, I already forgot the premise. Oh yeah, it's like delivery times, right? Like you gotta, and you just got to take my word for it that it's uniformly distributed, right? It's like, hey, the length of time for deliveries to our warehouse from the distribution center is continuously uniformly distributed from between X hours and Y hours. I ain't telling you the numbers. I'm not that nice, right? But, right, if you know the two endpoints, we call them A and B when you're doing continuous uniform, you know everything. That's all you need to know. If you know it's continuous uniform and you know the two endpoints, everything else falls apart formulaically. So you can get me a probability of little sections, you can get me an expected value, you can get me a variance, and I have you do all those things. So on this question 4, it's part A, B, C, D, E, F. Well, A is to draw the function. I want you doing this by hand. I told you I want a paper, pen, or pencil version of this, right? So it's a really quick sketch. It's a rectangle. The top of it's flat, 0 degrees, no pitch, no slope. Okay? And you just got to make sure you have the right endpoints. The height, you have to make sure you tell me the height. Well, if you know the width and you know that the thinking thing has an area of 1, then you know the height. It's just the reciprocal of the width, right? Okay. And then I hit you with some of these type questions. Hey, what's the probability that the delivery time is over 8 hours? How about that it's between 3 and 9 hours? How about that? So I've got those kind of questions. Again, really quick and just intuitive with the area of those rectangles. I do ask you for the expected length of delivery, right? And I do ask you for the standard deviation. There is a weird calculation for the variance or standard deviation of a continuous uniform. I think it's like, I don't even remember. And it was like, what is it? 1 over B minus A, no, 12 over B minus A squared. I forget what it is even. See, I used to remember that. Oh yeah, no, it's B minus A quantity squared over 12. That's it. I knew there was a 12 in there. Well, yeah, write it down. Make sure you know how to apply it, right? Check it with this number 31 here. Make sure you can do E just fine. And if you're applying, and if you can see what the formula is and apply it here to E on 31 as a practice thing, then just apply the same thought to my delivery time one on number 4. 33 here is a lot more fun, right? We even get some good content questions, Rhett and I do, from folks on 33, but 33 is so I like 33. It's more fun. And the stuff like in A and B here about the probabilities, I'd say those are on point as well. But the C and D are more kind of like thinking man questions about, a little bit deeper about what your motivation is and this and that when you're setting up your bid. So I don't know, A and B are fine, but I would say, unfortunately, this boring 31 is probably the best. All right. Anything? We're almost halfway. And we're finally leaving week 2, chapter 5. Anybody, anything? Just making sure. I guess you should peek at that chat bar that I'm always phobic of. No, all safe. Okay. Next, we shift into inference, and we're in week 3. Now, I don't have you calculating a bunch of t values, and you got to go use the t dist func, t dot dist, and t dot in dist, and right. That was the take home, right? You had your time to shine with that. So I don't have you doing any Excel calculations, of course. The whole point of this is I want you to be able to do it on paper. But what I do have is I have a scenario for you. And I want you to tell me whether the scenario I've given you is a one-sided test or two-sided. And if it's one-sided, you need to set up the correct sides too. Now, there's lots of folks, a lot of people on that take-home that didn't follow the advice about playing the prosecutor, where like, okay, you give the benefit of the doubt to the null hypothesis. Let that be the null. Let the conjecture be the null. And you're looking to play skeptic or prosecutor, where if we're giving the benefit of the doubt to the defendant there, letting them have HO, I'm looking for enough evidence to reject that claim as HA. So a lot of times I always think of hypotheses setups as like, oh, whatever I want to show deep down, whatever my inclination is, well, that's what I'm going to set up as my alternative, my HA, and I work in reverse, setting up my HO. Right? Now this goes hand in hand with a bunch of problems here from week 3. So I guess we should finally pivot out of good old week 2 and into week 3. Right? Do. Practice. Dun 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 dun. Practice problems. I always get frustrated with that ebook and stuff. I'm so old that I don't trust it sometimes. And it's like, I'll show them. I'm going to quietly make a Xerox of this just in case. I even call it a Xerox. That's how old I am. So I said like 25, 26, 27. Yeah, look at these. I like these. And there's a reason that I suggest that we peek at all of them here, right? 25, 26, 27, 28, 29. Okay. Ta-da. All right, well, 25. A production line operation is designed to fill cartons with laundry detergent to a mean of 32. Now, I like this example. I think this is clever, right? What's our hypotheses here? A sample of cartons is periodically selected and weighed to determine whether underfilling or overfilling is occurring. Well, they gave the store away right there, right? That's got to be two-sided because underfilling or overfilling are. And I like this one because it's like, oh yeah, underfilling would be bad. I might get sued by Ralph Nader or something, whoever runs the consumer product, whatever these days, right? Or if I'm screwing people on detergent, that'd be bad. But it'd also be bad if I'm overfilling the bottles and dumping, detergent all over the place, right? So, okay. So this time I really want to hit it on the nose on 25, right? 26, all right? 27. I mean, 27 gives it away that it's one-sided. They show you the hypotheses, right? So I often say you want to be on the lookout, right, for the mindset, and you got to kind of have your head screwed on right with these sorts of things about what's going on. So please look at 25, 26, 27, 28, 29, and think about the mindset that goes with this tied to that. So literally question A is I give you a scenario and I want you to tell me which of them it is. Is it one-sided with HA greater than? Is it one-sided with HA less than? Or is it two-sided? Those are your 3 choices. Then I ask you what a type 1 error and type 2 error are. So just like you see here in 27, in 28, in 29, right? And there's a little grid that's very famous in every stat class, and we've got it in our week 3 too. Let's talk about, well, if you reject and you're supposed to reject, then that's good. And if you fail to reject, then you should fail to reject. Well, that's good. Well, if you reject when you shouldn't have, that's type 1 error. When you fail to reject when you should have, that's type 2 error. I don't want you on this question, we're on 5 here. I don't want you to just use the canned verbiage. Type 1 error means you reject when you should. No. I want you to take that back and explain it in the words that go with the problem, right? So if I'm reading something like, excuse me, um, you know, Carpetland salespersons 29 average 8,000 a week in sales. The vice president proposes a compensation plan with new incentives. Steve hopes that the results of a trial selling period will lead to the conclusion that the compensation plan increases the average sales per salesperson. Right? Right. If we're in a setup like that, right, what does the type 1 and type 2 error really mean? I don't want verbiage like reject the null hypothesis when it's true. No. I want stuff like, oh, well, this means that we're concluding that the plan really works when it doesn't, right? Stuff like that. And I'm looking for a real spin on the scenario. Now, it's only a 2 or 3 point thing to do it right, but that's what I'm getting at. The next question I have for you ties, I got it on the hints here about going and checking out checkup quiz 3. I can't remember which number it is. And I don't remember if I've even shuffled the problem numbers for y'all. But if you go look at your checkup quiz 3, let's just go ahead and peek. I think it's the end. Let's see. Right. Yeah. So the company claims, well, what? So like 6 here is, right? Company claims 28% of its paint had been painted blue. I picked something boring because that one I wanted to be two-sided, right? But let's see. Da, 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 da. Ah, here we go. Here we go. Here we go. Right. I like this 10, right? I really think this 10 goes hand in hand with the last part of my question 5. You work for a company in quality control, and you're very suspicious that the mean of the distribution is smaller than the company claims. There's little risk if you get a false positive because you're only going to distribute your findings internally. So you want to be sensitive to incorrect claims. When you conduct your hypothesis test, right, which confidence interval would you want, which confidence level would you want to use? Now, you can go review the quiz answers or whatnot, but I didn't put 95 on the list. That's the kind of vanilla case, 95, right? I did 90 and 99 on this quiz question. And here I wanted you to be very aggressive. What if, and this is how I think, what if I did that in part because on the proctored final exam question, I was going to go the other way. On the proctored final exam question, I want you to be very careful. Yes, I want you to run the hypothesis test, but you don't have to crunch the numbers. I just want you to talk about it. But when you do the hypothesis test, I want you to be really careful. I only want you to reject if you're really sure. Making, right, a type 1 error would be really costly. All right, well then, if you're going to get away from 95, would you go up to 99 or down to 90? Why? Yeah, it's because I'm looking to do the converse on the exam questions we did back here. Oh, I've said too much. I've said too much. I know I'm a little bit more vague with that one, but say, I bet you can pick up on my scent, those of you that are dialed in material-wise. Right. What do you think? All right, we're making headway. 6. 6 is really fast. I felt obligated to ask you something from the non-sampling error part back in week 3, you know. I feel like, well, if I'm going to make you watch this for 35 minutes, sure, it's on your take home too. It's the first thing on your take home too, right? And of course, you're following the directions on that, right? You're not just writing down vanilla terms from the slideshow. You're actually commenting on why these mistakes from the HR department or whatever, this consultant are stupid, right? But I kind of feel obligated to ask you something here on the something else on the project final, right? So all I ask you is like, hey, like, what's the deal with sampling and non-sampling error? Like, what's the difference between the two? I mean, it's very foundational, right? This presentation is really about non-sampling error kind of thing. Sorry, that's my other class this afternoon. Right. So, yeah, sampling error, right? Before we introduce all these kinds of non-sampling or anything else, I basically ask you to explain the distinctions. It's like describe in a few sentences what the differences are between sampling error and non-sampling error. And then I say on the exam question, make sure you explicitly talk about like bigger sample sizes and would a bigger sample size help with sampling error? Would a bigger sample size help with non-sampling error? Right? Which of these can you measure? Sampling error? Can you measure this? Non-sampling error? Can you measure that? You can't miss it. I mean, it is the plot of the entire slide deck, presentation, or whatnot. It's only like a 5-point item. Here it's question 6 on your proctored final. It's most everybody will get it. It's just a big picture, mostly definitional thing. Again, with a plea to comment on the impacts of sample size and on the measurability, right? Which again, you can read right there. Dirt. Okay. How about a 7? All right. Stop me if you want while I'm moving into week 4. Week 4 practice. Now, if we peek at the practice part here, dun 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 dun. All right. I don't make you do the regression yourself. You're doing plenty of that right now on Take Home 2, right? So you're getting your fingers dirty with the Excel. That's the whole fun part, right? But so I say week 4, problems 6, 7, 8, 9, 10, and I say A through D, A through E, A through D, A through, I hope I labeled those right? So let's start at, oh, God, my kids have affected me with the 6, 7 thing. And so now I'm seeing it or hearing it just by saying the numbers 6, 7. Okay. Right. I've been brain rotted by my 9 and 7-year-olds. All right. You don't need to make the scatter chart for the data. Like, if anything, I think I screwed you over. I think I picked the wrong. I think I should have omitted A from these. Did I not do that? Am I a fool? Yeah, you don't need A, right? You don't need to do no scatter plot, right? Make sure that, so see, when I was editing this, I screwed up, right? Yeah, you don't need to do a scatter plot. You don't need to make the regression yourself. I'm going to give you the output. I'm going to give you the number of observations, the R squared, the adjusted R squared. I'm going to give you that ANOVA table that has the degrees of freedom, that has the F-test and its p-value. So I'm going to give you all the pieces here. Now, explaining the parameters and talking more about what's going on, that's the reason for these. But that A thing is bothering me. Sorry. So I'm distracted that way. So 7, 8, 9, which obviously is where one of your problems came from on the take home. Yeah, you don't need A. I'm going nuts. Sorry. So maybe I will take this down quietly and repost it quick for anybody that sees it, because that's the kind of thing that drives me nuts. Right? You're not doing the Excel or the coding. I just give you the output. Here's a bunch of tips up top. The first question now 7 is a big one because it's the big regression question, if you will, on this proctored final. I've got 4 different predictors. So you're running a multiple regression and you're going to try to predict one thing, that'd be your Y. And I got 4 candidates as potential predictors. So call them, X1, X2, X3, X4. Right? You run the multiple regression. You're going to get an intercept, like you always do, and then you're going to get coefficients and standard errors and t-values and p-stats or t-stats and p-values for all 4, X1, X2, X3, X4. I ask you, the same way I play on the take-home too, write out the model and don't use X1, X2, X3. Use the actual predictors. Like use the names that you're predicting as the X's, and then write down the coefficients next to them. You're multiplying. You're just setting up a linear function there, right? Write it down. But write it down descriptively so that I'm not seeing Y equals X1 plus X2 plus, B1 X1 plus B2 X2. No. Say, oh, I'm predicting revenue, equals whatever my coefficient is times internet ads plus whatever my coefficient is times direct ads and that kind of thing. Right? That's the first part, A. The second thing I say is, hey, explain what you get from the predictors. Right? Tell me in real words. Right? Just one sentence each. I've got 4 predictors. When you have an output table, right, and you can check the solutions manual that goes hand in hand, right, with these problems 6 and 7 and 8 and 9, right? yeah, you can see the questions here, but if you don't want to rerun the Excel, because you don't need to, you're not going to be asked to do it on the Proctor file. If you get the output, right, what does it tell you in words? So here on something like number 9 here, you're going to get a coefficient for TV advertising, right? And what it tells you, what if I get a coefficient for TV advertising of 4.4? Well, that means for every new dollar of TV advertising, my revenue is projected to go up $4.4, right? That's what I mean by just saying it in real words. But since I got 4 predictors on the exam one, you'll have 4 quick statements to make, right? That's the next thing to do. So write out the model, then actually tell me what the coefficients do in terms of moving the y for each of the x's. The next part of the question 7 here is, hey, right? Assume the residual plots are fine, right? How do I jointly test that all of the predictors are simultaneously 0? That none of the 4 in my case, or in this case here it would be 2, that none of them are predictive, but jointly, not individually, jointly. Now, I make a bigger stink about this than the book does. So when you go back to the slide deck and check on this just to make sure that you're looking at, right, this test here and how it's different than testing the individual predictors. The book doesn't talk as much about that. The package slides that they give us as teachers with the book don't talk as much about that. So, and by the way, if you think my slide decks are long, you ought to see how long they were before I got my hands on them. Now, don't get me wrong, I add some things too, but I delete more than I add. All right. Yeah. So yeah, there's a joint test. I'd make sure I'm ready for that. Um, I, this is actually the earlier part B. I ask you, well, what percentage of variation can you describe with this model? Well, there's something else right here in this hint paragraph before the highlighting that's exactly the right tool to tell you what percentage of variation your model is predicting or accounting for, I should say. Well, the Y go and I love the graphics for that, like with the rectangles, the boxes and stuff, and the Y bars and Y hats and Y all that from back in chapter 4. That I love that stuff. I love that stuff. Right? So how much of the variation is being explained on the whole from your explanatory variables? Last part. This was towards the back of week 4 of chapter 7. Last part. I'm going to spend a question or two, little sub question or two, asking you, hey, of your 4 predictors here, which ones are powerful? Which ones do you want to make sure you keep? And which ones are you potentially cool with getting rid of? If you want to be a little more on the nose, I'll reward you for listening to me for an hour now. You want to be a little more on the nose? Think about that backward selection that we talked about a little bit, right? Towards the back of the chapter or chapter 7, week 4 slides. Right? What a backward selection. If I was doing that, how would I decide what to kick out? That's what backward selection does versus what to keep in. Right? So be a little more vague here, but not that bad. What do you think? And I give you, say, it's a long one because of the pictures on the table. All right. I'm probably wearing you down with, as they say, right? I had a picture of this that Jerry's driving. Some of you know it over there. It's changed a lot over the years. It's not the same as my day, but like Jerry's driving. I love the head of poster used to say, it's like, you can't, what is it, dazzle them with brilliance and you baffle them with bull, you know what. And I always love that poster. Like, well, if nothing else, you talk long enough, they'll give up. Yeah. All right. Next, so 7, if you're thinking about it, is like a normal regression. You do it, you're allowed to do it, everything's fine. Just get into tell me all the pieces and what they mean. 8 is not like that. I have another regression for you. But this time, something goes weird. Right? So that's the point of a question. Now, it's not as many points. Like I got like 20 points or so on question 7 and only like 6 or points or whatnot on this question 8. I would just point you towards, hey, I know it was a pain in the butt, but I had those extra examples here because the book doesn't do a very good job of like demonstrating, issues where the residual plots are bad. They don't do a very good job of that. Right? So I got a quadratic example here. I got an interaction example here. Right? They also don't do a good job discussing via example multicollinearity in my experience. Right? So, right, I would implore you checking out these and then back there as well in your week to be ready for everything in your week 4 area, right? I've got a couple timestamps on this. The issues there about quadratics, for example, from the hour 27 to hour 42 mark. And then I got about 8 or 9 minutes on multicollinearity in the part 4 slides from like the 108 mark to like the 117 mark, right? So, hey, what are the symptoms of those problems? Now, the example I created, it sticks out like a sore thumb. If you've followed along with these issues, then you'll see pretty quickly. I give you some output and there's stuff about it that's problematic. And I even give you hints on number 8 where I'm like, hey, that's weird. Look at this. I kind of effectively give you a clue to nudge you towards the answer. And then I give you some alternative model instead. So, what do you think about this kind of thing? It's only a 6-point question out of 100, but I basically say, like, hey, you know, what's wrong with this? And identify it explicitly. Don't try to mealy mouth your way through it. Tell me the terms for like, what's bad here, right? And then tell me what you think about some alternatives to this kind of thing. Again, fewer points because this is kind of this is more vanilla, if you will, number 7. And this is like reverse strawberry shortcake, Rocky Road Delight, number 8. So way fewer points, but finally, 9. Now, did you notice? You've been doing some take home too, I suspect, right? Did you notice on take home 2, right? If you look at week 5, and I don't even know that I want to go into the practice. I guess I should. If you go to week 5, right? I don't even need to open the slides in full, I don't think. I think just peeking at them is enough. Right? Here's the practice problems. Are we ready? I promise I'm 5 minutes from done. I promise, I promise, I promise. Right? I say on the list here, I say, well, look at problems 5 and 6, B through D, because again, I don't need you to do the scatter plot or the trend plot. There's no plot to do. Look at number 5 and 6. And I say, I think 6 might be best. It's a small, simple question with a few observations to do by hand. Yeah, definitely. You look at 6 here. Do, 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 do. Yeah, they got like 7 observations. They ask you to do a 3-week moving average and its MSE. They ask you to do a 0.2 exponential smoothing and do its MSE and then compare and talk about what's better. You don't need to do E. There's no trial and error component. I'm going to give you a specific alpha to use for exponential smoothing and you are free to roll with it. That's it. You're done. Right? But I will have you do a naive forecast. Which is really easy, right? Because for week 2, your naive forecast would be 24, since that was the previous. For week 3, your naive forecast would be 13, and so on and so forth. So I have you a table, see? I've got you a table where, like, didn't you think it was weird that you did all this time series lesson, and then the only time series thing that you're doing on take home 2 doesn't really show up until I'm killing for time. It doesn't show up until the end, right? The stuff you're doing on take home 2 from time series is, come on, you son of a gun. There we go. Starting around this, it's coming. There. It's the regression part. You're doing time series regression on the take home. You don't do any time series regression on this. There is no take home, there is no time series regression on the proctored final. Then why the hell did I put you through 40 slides of it? Well, because this is question 9. Here on question 9, I've got you doing an exponential smoothing, an MSE for it. I've got you doing a moving average and an MSE for it. I've got you doing a naive forecast and an MSE for it. So all this stuff here comes to a head on this final question on your proctored file. It's number 9. It's got ABC. It's got 4 parts, A, B, C, D, and it's basically, I give you, say, like a table that you could copy onto your paper. So I say, hey, you can use a table format like this and just fill in the rest of your picture on like a homemade hand-drawn table, right? And the idea is it's going to look something like this. I've only got, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9 observations. So again, I think something like this that's pretty fast and simple, that only has 7 should be just fine, right? As practice, I ask you to, in each case, give me the next period's forecast for all 3 methods. I ask you to give me the MSE for each of the 3 methods, and then tell me which one's best. The one that's best is the one with the lowest MSE, and you're done, right? But say that to me, in theory, I feel a little bad that don't have a great Excel tool for this. But cripes, I mean, come on. The naive forecast is literally just the period before. The 3-period moving average, I only got 9 observations. I think you can take 6 little averages with a pocket calculator. Shouldn't be bad. I guess I could feel a little guilty, right? That for exponential smoothing, you got to do a quick calculation. So make sure you have your exponential smoothing, calculation formula, if you will, down, and that you practice with it a wee bit by hand. They're fast, and there's only 6 periods or so of them to do. Well, that's a lie. I guess it's 8, right? So are you out a huge loss by not having the analysis tool pack in Excel? I don't think so. It's like a 3-point task, right? And you can do it with a pocket calculator pretty fast. And that's it. We're done. Mm-hmm. I heard a few people probably leave because they probably, well, no, it's up at the same number. Anything I'm forgetting or that you want me to try to clarify? So I'm trying to give the store away. That's why it takes a while, but.
Yeah, so again, just one more clarification on this. Um, I, I I think this is the first kind of test at least I've had like this. I
Mhm.
get the indication that maybe that the work is meaningful, being that these aren't
Okay.
all multiple choice or something, right? So
Right.
on parts where it's kind of sort of obvious, if we have the right answer, but there's not a ton of work, is that okay? And then on the flip side, is there kind of a buffer or a hedge for if we arrive at the wrong result, but we're kind of on the right track with the work, that there's like
It
fractional points or something?
It frankly, I don't want to BS you. The way Rhett grades is a little less forgiving on the partial credit front because, but that's because there's so many teeny little pieces here. So it's like there are 30-ish calculations to do, but they're so small, most all of them individually, that when he assigns like 1 point to this and 2 points to that and 1 point to this and 2 points to that, I kind of sign off on it. Now I think you're going to want to show the calculation, for yourself to work things out, even if it's a simple quotient or product or something like that, Brandon. But I would not go out of my way to like turn a 1-step calculation into a 3-step calculation just for the sake of potential partial credit. I don't really think it'd be worth it, frankly. I'd keep an eye on the clock. I mean, if you feel like if you look at the thing for 30 seconds and within a half hour, you feel like, okay, yeah, I've got plenty of time and I can be more deliberate and explain, then you might save yourself a couple points here or there. But, I would Most of them are pretty direct. So, there is some partial credit to it, and there are some things where a miss on one piece um, will be deducted less because of, you can see that it came from an earlier error. But for the most part, like I would just do what you need to do.
Got it. Okay.
Anybody? Bueller. Okay. Okay. Well, I hope this compiles tonight so that some of you might even see it here Tuesday night the 2nd. But if not, I'll try really hard to get it up as early as I can tomorrow the 3rd because I know folks chomp at the bit for this. It's I like take home 1 and 2 Zooms. I want to be helpful and give folks stuff. But on the flip side, it's like, you know, you can read the questions yourself and you got a couple weeks. So, you could probably put it together if you really had to. Okay. Well, thank you all for your time. All right. Enjoyed it. I'll go see what the ruckus is about. All right. Oh, let me see. Did I miss somebody? Oh, you're very welcome. You're so kind. Okay. Thanks, everyone. Have a good evening.
Thank you.
Thank you.
Bye.
Thank you.